Greetings, math fans. All right, so this is day one of the chapter called Sequences and Series. So let me just give you a little idea of what a sequence and what a series is. A sequence is like a list of numbers. Okay, some pattern to the numbers. It could be multiplication, or it could be addition. It could be like 2, 4, 6, 8, 10, 12. Or it could be 2 and then 4 and then 8 and then 16, 32, 64, going up by multiples of 2. That's what a sequence is. A series is basically the sum of those numbers. So if I add, numbers between, 5 and 20 together, or even numbers between 33 and 76. So if I add those together, that's a series. All right. So let's get started. This is going to be day one. And the title of day one is called Arithmetic Sequence. Okay, arithmetic sequence. And if I define that, it's a sequence in which each term after the first, and we denote the first as a sub 1, that's the first term, is equal to the sum of the preceding term and the common difference. We call the common difference D. Okay, so just a real quick example would be like 4 and then 7. So it went up by 3 and then another 3, 10, then 13 and 16. That's an example of an arithmetic. That's kind of how you say it too, as opposed to arithmetic. It's an arithmetic sequence. So our common difference, which again is D, is equal to, in order to find that out, you take the term and you subtract the preceding term. So it's basically 7 minus 4, which is 3. Or, you can say you want to check a couple of them. So 10 minus 7, 3, etc. Okay? So that is your common difference D. So let's develop a formula here, math fans. Alright, so if I tell you guys a sub 1 is 4, and then a sub 2, I'm going to say 4 plus, and this is, again, just using our same numbers here. So let's actually write them out here. 4, 7, 10, 13, and 16. So 4 plus, and then it's going to be 3 and 1 of those. Right? And then a sub 3 is 4 plus 3, and we're going to do 2 of those. A sub 4 equals 4 plus 3 times 3 of those. Right? Let's do one more. A sub 5 is 4 plus 3 times 4 of those. Okay? So do you guys agree that if I come up with a formula, a sub n, this is called like the nth term. Okay, a sub n is, all you got to get the first number here too, right? A sub 1. So a sub n equals a sub 1 plus d, right? So this is your a sub 1 plus your d, common difference, times what? Well, look at this. See this number right here? See how that's a 1 there, and that it's a sub 2? So it's always 1 less than that. Do you guys agree with that? Always 1 less. So we call this n minus 1. Because n is your n is basically the number of, or the term number. That's what n is. Okay? A sub 1 being your first term, d common difference, and a sub n being your nth term. right? A sub n is the nth term, like the first term, second term, fifth term, 20th term, 100th term, etc. So this nice little friendly formula right here is your equation for arithmetic sequence. You guys want to put like some stars on here? There are going to be 5 formulas you're going to have to memorize. This one is huge, 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 huge. So it's got like whatever stars, moons, green clovers, whatever you need to put around this thing. Really, really important. Okay? All right, so again, we have all our terms here. We have, that's the nth term, that's the first term, that's the common difference, and that is the number of terms. And by the way, the n, the number of terms, is always going to be a natural number. Natural number means not including 0, 1, 2, 3. So it's integers starting from 1. That's a natural number. Because think about it, you can't have the negative 5th term, or you can't have the 0th term. It's either the first term, the second. Can't have the 1.6th term, right? It's always going to be an integer greater than, from 1 and greater. Okay? Basically, I can ask you to find any variable in this. So I would give you enough information. I can say find any of the variables. Okay? All right, so let's do a couple examples here, math fans. I'm going to say find the 105th term in the arithmetic sequence -20, -24, -28, and dot, 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 keep going. All right. So we got to find, in order to find that term, just think about it. Let's write this out. It's a sub n equals a sub 1 plus d times n minus 1. Well, first of all, n is easy. N is the 105th term. That's a piece of cake. Our a sub 1 is right here, math fans. It's the first term. A sub 1 is -20. All right, so I've got that. I've got n. I just need d. Well, d is the common difference. Remember, the common difference is you always take the term and you subtract the preceding, the one before it. So d is -24 minus the one before it. So be careful with the double negatives here, right? So d is -4. It's a good idea to check it just to make sure it's good for at least 2 terms. So if I said -28 minus a -24. So that gives you -4 as well. So d is -4. And then we plug it in. So it's a sub 105 equals a sub 1 -20 plus d. So it's -4 times 105 minus 1. Really, really easy. Okay? So you get a sub 105 is equal to -436. Okay? Not too bad. Let's keep going here. Let's do a couple more examples. This is a little tricky. So I'm going to tell you guys a sub 4 is 38. A sub 13 is 155. I'm going to say find a sub 22. Now I'll tell you, of course, this is arithmetic. I have to tell you that. Because you don't really know that. So if I tell you it's arithmetic, let's write the formula out again. A sub n equals a sub 1 plus d times n minus 1. Well, we kind of have an issue here, math fans, because we don't have a sub 1 or d. Right? Don't have a sub 1 or d. So what do we do? Well, we kind of have to rewrite things. We have to almost like make a temporary thing. We're going to rewrite. Instead of a sub 4, the difference, if we once we found out d, this is a sub 4 and this is a sub 13. The difference between these is 9, right? 13 minus 4 is 9. So it doesn't matter if that's the 100th term and that's the 109th term. There's still 9 difference between them, 9 values of d between them. So what I can do, I can rewrite this as a sub 1 is equal to 38. And in order to go from a sub 4 to a sub 1, I subtracted 3. So I can say a sub 10 is equal to 155. And then I can say find, and I subtract 3 there, and I can say find a sub 19. Guys, this is it's the exact same problem as the original problem. The spacing is all the same. There's still 9 difference between a sub 1, a sub 13, and a sub 1, a sub 10. You're not doing anything different. I just rewrote it. Okay? Very, very simple to do. And now what I can do is I can find d. So now find d. So, well, a sub n is this term right here. We're going to make it that. We're going to say, oh, it's a sub 10. So it's 155, which again is a sub 10, is equal to a sub 1, which is 38, plus d times, and now we know, just because we wrote it, our n is 10. 10 minus 1. That's going to give us the value of d. So you get 9d, move that over, is going to be equal to 117, so d is equal to 13. There we go. Now we have d is 13. I have my a sub 1 is 38. Now I can find a sub 19, which is my ultimate goal here. So a sub 19 is equal to a sub 1, 38, plus d times 19 minus 1. Right? That's your n, the 19th term. So a sub 19 is equal to 272. Okay? So again, when you got numbers in between like that, you still the gap is still the same. There's still 9 between them, but like I said, just rewrite it. It's really, really pretty easy problem, and just make sure you rewrite. Get all 3 of them right. We start out as 4, 13, and 22. I subtracted to make that a sub 1. So I subtracted 3 to make that a sub 10, and to go from a sub 22, subtracted 3, and I get a sub 19. Okay, all right, sounds good so far? Here, let's try another one here. If I tell you a sub 5 is 10, a sub 8 is 22, and I say find a sub 1. So this is a little bit different because I'm asking you to find a sub 1 now, so I can't subtract 4 from each of these, and especially subtract 4 from this guy, because that would be a sub negative 3. You can't do that. Okay, because you can't have a negative number. You can't have an a sub negative number. So what I need to do is I still need to find the value of d. So I still need to find d. So I'm going to do a temporary change. And what I'm going to do is I'm going to make this temporary. It's going to be a sub 1 is 10, just like I did before. So I subtracted 4. Subtract 4 from that, I get a sub 4. So I'm not even worried about that a sub 1 right now. I'm just finding d. Okay, I'm just finding d. So here we go. Let's do 22 a sub 1 or a sub n equals a sub 1 plus d times 4 minus 1. Okay, so I get 3d, move that 10 over, 3d equals 12, d is 4. Now I can go back to the original problem. Now I can use, oh, it doesn't matter which one I use. I'm going to use a sub 5. So it's a sub 5 is 10, d is 4, and I want to find a sub 1. Okay, pretty easy now, right? So a sub n is 10, so a sub n equals a sub 1 plus d times n minus 1, 5 minus 1. So 10 equals a sub 1 plus 16. So a sub 1 equals negative 6. There we go. All right, not bad, not bad. All right, so that's some basic problems just with arithmetic sequences. Now I want to do something with arithmetic series. So let's title that arithmetic series. Okay, so basically it's the sum. That's what a series is. It's the sum of the arithmetic sequence. Sum of the arithmetic sequence. So let's think about it. If I give you 2, 3, 4, 5, and 6, right? And it keeps going here. Well, let's actually just cut off here. So 2, 3, 4, 5, 6. And I ask you to find the sum of that. Do you agree it's 2 plus 3 plus 4 plus 5 plus 6? So the sum is 20. Pretty easy, right? Well, another way of looking at that, I mean, yeah, I could add it all up, but I got to find a better way to do that. Because if I just gave you 2 through 6, it's really friendly, right? What if I said 2 through 50? You'd be like, oh man, 2, 3, 4, 5, you add it all up. Well, think about this. Do you guys agree I could take the average of the extremes? So if I said 2 plus 6, the average of the extremes, which is 8 over 2, which is 4. So the average of the extremes, and then multiply that by the number of terms. Kind of cool, actually. So again, our average of the extremes is 4. There are 5 terms. 20. That's actually kind of slick. Okay, so it's the average of the extremes, then multiply that by the number of terms. Okay? So let's actually come up with a formula here. It's really, here's the formula, S sub n. This S stands for sum, equals the average of the extremes. So it's a sub 1 plus a sub n being the last term, a sub 1 being the first term. The average of those times n being the number of terms. Okay? So again, this is one to put stars, moons, whatever you want to put, squares, around there. That is super, super important formula. Okay, got to know that one. That was arithmetic series, the sum of a sequence. Okay, so let's use that equation here in this next example. So example is find the sum of the first 10 terms of the arithmetic sequence 3, 7, 11. Now it's nice that I told you it's arithmetic. I didn't actually even have to tell you that, but you can figure it out by going, oh, well, gee, what's the difference? 7 minus 3 is 4, 11 minus 7, 4. Oh, it is arithmetic because the difference is 4. Okay, so let's write that down. Difference is 4. The first term is 3, and n is 10. That's pretty much what you're given, right? You guys agree with that? And let me just write that formula out again. S sub n equals the average of the extremes, a sub 1 plus a sub n over 2 times n. So let's see, I'm given a sub 1, which is perfect, I can use it, and n is 10. The only thing I don't know is a sub n. Well, a sub n is the last term. Well, or it's the 10th term, right? So before I can actually find the sum of this, I need the first term and the last term. So I got to find the last term, a sub 10. A sub 10 equals a sub 1 plus d times n minus 1. So a sub 10 equals 3 plus 36. So a sub 10 equals 39. Okay, so now I can use that and plug everything in the formula. So it's s sub 10 equals the first term, which is 3, plus the last term, 39 over 2. It's the average of the extremes times the number of terms. Okay, and if you do that, you get s sub 10 is equal to 210. Sweet. All right, so I'm not necessarily going to hand you the 10th term in the first term because that'd be too easy, but I might just give you some information about it, and you got to find that last term. All right, cool. Let's do another example. Given S sub 31 is 5,580 and A sub 31, the value of that 31st term is 360. I want you guys to find the first term and D. That's pretty tough. If you didn't know the formula, how do you do that? I'm telling you, the sum of the 31 terms is 5580, and the actual 31st term is 360. Find the first and the difference. I don't know. I have no idea how to do it otherwise, other than using the formula. Okay, so let me just write the formula on the side here because I think that's important. S sub n equals a sub 1 plus a sub n over 2 times n. Okay, so let's write this out. We got S sub 31 is 5580 is equal to a sub 1, we don't know that, plus a sub n, we know that, that's 360 over 2, right, times n. So it's just a matter of algebra. That's all it is, math fans. So I divide both sides by, multiply both sides by 2, right, to get rid of this 2 on the bottom here. And so we get 11,160 equals 31 times a sub 1 plus 360. Divide by 31, so we get a sub 1 plus 360 is equal to 360. And a sub 1 is 0. Wow, all that work. Brutal. A sub 1 is 0. Okay, and then we want to find D. So we plug it back into the a sub n equation. So let me write that out. A sub n equals a sub 1 plus d times n minus 1. So a sub n is 360 right there. 360 equals a sub 1, which is 0, plus d times 31. That's n minus 1. So you get 30d is equal to 360. So d is equal to 12. Okay? That's two good examples. Okay, so this last question, it's a great ACT question. So I'm going to label this great ACT question. Oh, it's so awesome ACT question. All right, so here's the deal. I want you to find the sum of all odd numbers between 8 and 50. Oh, that's a great question. Okay, because you can sit there with your calculator and you go, oh, well, I can do 9 plus 11 plus 13 plus 15, and you work your way all the way up to 49. That would take you, I don't know, 30 seconds to do that. That's great. But I could say find the sum of all odd numbers between 8 and 500. And that would take you like 5 minutes because you'd be pushing plus in your calculator. Maybe get it wrong, maybe get it right. It'd take you way too long to do that. So we can use our knowledge of sequences and series to figure this out. So let's think about that. I want to find the sum of all odd numbers. So let me write out a formula. S sub n equals a sub 1 plus a sub n, sum of the extremes, times n. Well, do you guys agree that a sub 1 is going to be, it's an odd number, so it's 9, and a sub n, I'm going to write a sub n. It's really our last term. I don't really know what the n is, but our last term is 49, right? So do you guys agree? I have a sub 1, I have a sub n. I don't know n. Ugh. I mean, n is really the number of terms in there. I don't know how many terms is there between 8 and 50. Well, I don't know that, but I can figure it out. Can I use a sub n equals a sub 1 plus d times n minus 1? Well, I know the last term is 49. I know my first term is 9. And d, what is d? Well, let's think about it. It doesn't go 9 to 11 to 13 to 15. Isn't d 2? In fact, if it was even numbers, wouldn't it still be 2? So it is. It's 2 times n minus 1. So subtract that over, and I get 40 equals 2 times n minus 1. Divide by 2, I get n minus 1 equals 20, so n equals 21. Pretty sweet. Now I have all the information. So S sub 21, now I know it's 21 terms, is equal to the first term plus the last term, which is 49, over 2 times the number of terms, which we know is 21 now. And you get S sub 21 is equal to 609. Great ACT question. To find the sum of the first 21 terms using that nice little friendly formula. It's awesome. All right. So anyway, that is day 1 of sequences of series. And again, I introduced you guys to arithmetic sequence. I introduced you to arithmetic series. And make sure you know those 2 formulas and how to solve for any one of those variables. And we'll get into more of that and some other type of problems as we move on through the chapter. All right. That's it, math fans. Have an outstanding day. Adios. Goodbye.